Hello everyone, welcome to Math World. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is a pure mathematics 3 for May-June 2018, and the code is 9709/33. So let's move on to question number 1. For question number 1, expand 4 over square root of 4 minus 3x in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So first of all, I will just copy down the question. Okay, so the square root in the denominator will be moved up, and it will be 4 times 4 minus 3x to the power of negative half. Okay, so to do this expansion, we need to refer to the binomial expansion, which is 1 plus x to the power of n, because the degree of the expansion is not positive integer. So therefore, we have to use this formula, that is 1 plus nx plus n minus 1 over 2 factorial x squared and so on. Alright, so now from here, firstly, to use this formula is our constant is 1. And then followed by plus. So now since we have the 4 and the minus here, that means to get the 1 from 4, I will factorize 4. Okay, and then I will be getting first term as 1. Now remain the sign as plus, therefore the minus will be combined with the 3x. But we have factorized the 4 from minus 3x, that means you will be getting minus 3 over 4x. Okay, and with the same degree, negative half. Then from here, when you compare, that means your x becomes negative 3 over 4x now. Okay, and don't forget, we need to bring in the degree. So this negative half will be bring into the expansion and also bring into the 4. So then I will be getting 4 times 4 to degree negative of half, that is going to be 1 over 2. Okay, then I will be getting 1 plus negative 3 over 4x, then with degree of negative half. Then from here, 4 times half, you will be getting 2. And now, for this expansion, you can just direct apply this formula. Okay, which means now here, I will be getting 1 plus, my n becomes negative half. So, n x is negative 3 over 4x plus then n times n minus 1. The n is negative half. So when you minus 1 from negative half, that is negative 3 over 2. Then over 2 factorial. After that, negative 3 over 4x squared. And now we need to expand until x squared. That means I will just stop my expansion here. Okay, and when you simplify the terms inside the bracket, so first term remains as 1. Then the minus half times minus 3 over 4 is basically plus 3 over 8x. Then this whole term, when you simplify, right, bring in the square to the negative 3 over 4, at last you will be getting plus 27 over 128 x squared. Now for the final answer, just need to expand, multiply the 2 into the whole bracket, then you will be getting 2 plus 3 over 4x plus 27 over 64 x squared, sorry. So this is the expansion for this question. Question number 2, showing all necessary working, solve the equation 5 to the power of 2x equals to 5 to the power of x plus 5. Give your answer equal to 3 decimal places. So when solve means that you need to find the unknown, that is the x. Okay, we need to find what is the x. So from here, I will write 5 to the power of 2x equals to 5 power x plus 5. So I will just move all the terms to the left-hand side. Then you will be getting 5 to the power of 2x minus 5 to the power of x minus 5 equals to 0. And I will be using the substitution. Let's u equals to 5 to the power of x. That means my u square is going to be square of 5x. That is going to be 5 to the power of 2x, because we have this formula, a to the power of m with degree n, that is going to be a to the power of mn. Okay, then now here I will be getting a quadratic equation. So first term becomes u squared, second term is u, third term minus 5 equals to 0. And this quadratic equation cannot be factorized. Therefore, I will be using the quadratic formula. So quadratic formula ax squared plus bx plus c equals to 0. Then from here, my x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, so which means now for the quadratic equation in terms of u, I will write down all the coefficients. So the coefficients for u squared is 1. That is my a equals to 1. Then the coefficient for u, this is minus 1. Okay, because it's minus u here. Therefore, I will write b equals to minus 1. Then the c is minus 5. And now, when you compare the quadratic equation, the general form with the quadratic equation that I have obtained now, my x is basically changed to u. That means I have to change accordingly if I apply my formula. So that means u equals to minus b plus minus square root of b squared minus 4a is 1, c is minus 5. Then over 2a. Okay, your a is 1. Then from here, when you simplify, you will be getting 1 plus minus square root of 21 over 2. Then that will be negative 1.79129. I give more decimal places, and the other value is 2.79129. Okay, now remember, we need to solve the equation in terms of x. And now we have used the substitution to change to u. Okay, which means now I have to change back what is my x. So my x is to be replaced by 5, my u is to be replaced by 5 to the power of x. Okay, so now I will write 5 to the power of x equals to negative 1.79129, or 5 to the power of x equals to 2.79129. Okay, so when you need to get the x, we need to take ln both sides. So but then when you take ln, that is undefined. Okay, so ln 5x equal ln 5 to the power of x equals to ln of negative. So ln cannot be negative. That means this is undefined or no solution. Okay, so now we need to solve the other equation. So now ln 5 to the power of x equals to ln 2.79129. And we have another formula, ln a to the power of b, that is b ln a. That means the x can be brought down for the left side. So x ln 5 equals to ln 2.79129, and to get the x, just move down the ln 5. So you are getting this division. Therefore, the answer will be 0.6378. And now look at the answer. Sorry, look at the question, given 3 decimal places. Therefore, I have to round up. So it will be 0.638. That is my solution for this question. Now next question, number 3. Showing all necessary working, find the value of this integration, giving your answer in terms of pi. So now integrate 0 to pi over 6 x cos 3x dx. Now, since this is multiplication of 2 different types of functions, that means we need to integrate using integration by parts, right? So for integration by parts, that is integrate u dv over dx with respect to x. That is uv minus integrate v du over dx with respect to x. So now the u is algebraic, which is our x, alright? That means now here, your u is going to be x, because your x is the algebraic. The cos 3x is the trigonometric, right? So now, from here, your u is x, so I need to find du dx. So your du dx is 1, and then the dv dx is cos 3x. So now when you integrate cos, our formula, integrate cos mx plus b. This is sine, because when you differentiate sine, that is cos. Then after that, over m plus c. This is the formula. Therefore now, when you integrate cos 3x, I will get sine 3x. Then differentiate 3x is going to be 3. Do not plus c here, because this is the working. Alright, it's not yet final answer. So now, use the formula, that is uv. So x sine 3x over 3 minus integrate v du. So when you multiply, that is basically 1 over 3 sine 3x. So I will factorize the 1 over 3. Okay, and now with limits, so you just add on the limits. 0 to pi over 6. So with limits here, I need to add on a, b, and then consider limits for all. So this is the integration by parts formula. Now, I have to replace the values. So I will factorize this 3. So it will be 1 over 3. Then x sine 3x. The x is replaced by pi over 6. So I'll get pi over 6 sine 3x. So 3 times pi over 6, that is 3 pi over 6. That is also pi over 2. And then you minus when the x is replaced by 0. So probably I just close the bracket later. So when the x is 0, whole term is 0. Okay, now minus 1 over 3. When you integrate sine, okay, we have another formula. Integrate sine mx plus b dx. So integrate sine is basically negative cos. So this is negative cos mx plus b over m plus c. Okay, so now when I integrate sine 3x, I will be getting negative cos 3x over 3, and together with the limits. So from here, I will be getting, okay, sine half pi is basically 1. Here is 1. Therefore, 1 over 3 times pi over 6, that is pi over 18. Then, now, look at here. This minus becomes plus. This 3 I move out, that is 1 over 9. Therefore, it is plus 1 over 9. Then after that, substitute the pi over 6 into the x. So I will get cos 3 pi over 6 is basically pi over 2. Then minus when the x is replaced by 0. So you are getting cos 0. So now cos pi over 2 is basically 0, but cos 0 is 1. So therefore, the question here show or find the value in terms of pi. Okay, that means now here I will be getting pi over 18. So this 1 over 9 times minus 1, that is minus 1 over 9. So from here, to get the simplest form, you can just factorize a common denominator. That is 1 over 18. Then I will be getting pi minus 2. So that is the solution of this question. Question 4. The curve with equation has a stationary point at x equals to p. So whenever you see stationary points, means that the dy dx equals to 0. And now first part, show that p satisfies this equation. Alright, so now what I need to do is, I will have to differentiate this rational function. So since it is the division of two different types of functions, or both also in terms of x, then I will just apply the quotient rule. Okay, quotient rule is d over dx u over v. Then that is going to be over v squared. So keep the v, differentiate u is u prime, minus keep the u and differentiate v to get v prime. Then from here, I will just write down my u is basically ln x. So the u prime, that is the du dx, right? So u prime or equals to du dx. When you need to differentiate ln, our next formula, differentiate ln fx, that is basically over fx. Then the numerator is f prime x. So which means now here I will write over x first, because after the ln, that is the x. So when you differentiate x, to get 1. Okay, then now the v is going to be 3 plus x, which is our denominator. So the v prime, it will be 1, because differentiate 3 is 0, differentiate 1x is 1. So now I will just apply this formula, which is a quotient rule. Your dy dx is going to be over v squared. So square of 3 plus x, then v u prime. So 3 plus x times 1 over x. That is my vu prime minus uv prime. So ln x times v prime is 1. That means now here, when I simplify, right, and notice that the first term I need to multiply with 1 over x. That means this is the denominator. So I have to factorize the denominator and make it the same denominator for both numerators here. So which means I will write 1 over x, then 3 plus x. So when you factorize 1 over x from here ln x, I will have to times the x to the ln x, right? That means now here you will be getting minus x ln x. Then over square of 3 plus x. And from here, right, I will just refer back to the question. Given that the curve has a stationary point, means dy dx equals to 0 when the x equals to p. So now you need to show p satisfies this equation. That means actually this equation, the x is same as a p here, right? So I will just write when x equals to p, your dy dx equals to 0. So now left side will be replaced by 0. Then right hand side, this is going to be 1 over p. Then 3 plus p minus p ln p, because the x is replaced by p now, over 3 plus p squared. Now go back to the question. You need to prove this. Ln x equals to 1 plus 3 over x. So firstly, I have to times this to the 0. Then you will be getting 0 equals to 1 over p times 3 plus p minus p ln p. Okay, then from here, I know that my p is the x value. That means now when you look at this equation, the products of two terms, right, these are the two terms, equals to 0 means one of them must be 0. But we know that 1 over p cannot be 0, because a p is the x coordinate. Therefore, I will just write 3 plus p minus p ln p will be 0. Okay, so then go back to the question. We need to prove ln x as the subject. That means now the minus p ln p will be moved to the other side. So I will get p ln p equals to 3 plus p, because we are just moving the minus p ln p to the other side. The 3 plus p remains on left side, but now I will write it on the right side now. Okay, and when you look at the question here, I need 1 ln x. So that means I have to divide the whole equation by p to get ln p equals to 3 plus p over p. So now I will split it into two terms. That is 3 plus p, and p plus p, it will be 1. And now I will rearrange because we need to get ln x equals to 1 plus 3 over x. So here I will just write ln p equals to 1 plus 3 over p. And remember, the p is the x value. So therefore, I will just write x satisfies ln p equals, I will write p satisfies. Okay, p satisfies ln x equals to 1 plus 3 over x. So this is how we shown the equation. Okay, now part 2, by sketching suitable graphs, so two graphs here, or more than one graph, show that the equation in part 1 has only one root. Okay, so now I go back to the equation in part 1, ln x equals to 1 plus 3 over x. So ln x equals to 1 plus 3 over x. But given here, the hint is you have to sketch more than one graph. So I will let y1 equals to ln x. And then y2 equals to 1 plus 3 over x. So the equation, when I split it into two equations, which means the root is the x values. So when y1 equals to y2, that is the intersection point. So now I have to show that there is only one intersection point between these two graphs. So now ln x this is our ln x graph. Here is 1. Okay, y equals to ln x. Now for information, if you need to sketch 1 over x. So 1 over x is like this. It will not touch the x and y axis. This is y equals to 1 over x. Whenever the numerator is positive, it will be in the same shape. Alright? So even though this is 3, you just enlarge it. Right? Therefore, here the plus 1 means it is a translation. So translation means that initially the graph never touched the x-axis. So now when you move up, so when I move up, that means it will not touch 1. Okay, so your x-axis becomes 1 now. So that means now I will be sketching the 1, that is our asymptote. Okay, let's say here is 1. So it will be the same shape, but just move up the whole graph by 1 unit. That means now here I will be getting this graph. So initially, this part cannot touch the x-axis. So now when you move up, it becomes cannot touch the green line, the dotted line. And same goes to this part. When this part, the originally cannot touch 0. So when you move up 1 unit, that means it cannot touch the dotted line. So which means now my graph will be approaching the dotted line. Okay, this will be my graph. Right? So from here, when I will label these two as y equals to 1 plus 3 over x. So obviously from the graphs, right here approaching infinity, negative infinity. So from the graph, there's only one intersection point. So therefore here I will just write there is only one intersection point between two graphs. Hence, ln x equals to 1 plus 3 over x has only one root. Okay, so done for this question. Now part 3, it is given that the equation in part 1 can be written in this form. Use an iterative formula based on this rearrangement to determine the value of p correct to 2 decimal places. Give the answer of each iteration to 4 decimal places. Okay, so we are going to use this formula, okay, and change to iteration. Because of iteration, I need to introduce the subscripts. So the subscripts will be n plus 1 for the left side and the n for the right side. Then here you will be getting this iterative formula. Now, from the formula, you need to find the p. Remember, the p is the intersection between these two lines, or these two graphs. So then you have to decide what is your initial value of the x, right? So since it is greater than 1, right, that means I can just let it be 2. Okay, so you can let it be 1.5 as well. So I will let x not be 2. Then now I will be substituting this x naught into the formula to get x1. That means your n is 0. Then the left side, it will be x of 1. So you will be getting 3 plus 2 over ln 2. Then this is going to be 7.2135 because it's mentioned results of each iteration 4 decimal places. And now here I will have to find x2 because from x naught equals to 2 change into 7.2135. So it's a huge difference. So now we have to find x2. So again, replace the xn by the x1 now. It will be 3 plus 7.2135 over ln of 7.2135. Then this is going to be 5.1689. Okay, so again, they are not the same. Now, when to stop, it depends on your answer here. Answer 2 decimal places means that we are expected to get identical 2 decimal places, or if not identical, it will be approximate equal, right? So now here, I need to find x3, that is going to be 3 plus 5.1689 over ln 5.1689, and this is going to be 4.9730. So for the x4, this is going to be 3 plus 4.9730 over ln 4.9730, and now here you will be getting 4.9706. Okay, so as I've mentioned just now, you need to get your answer correct to 2 decimal places. That means now here 97, this is 97, and I know that I should stop here because this is 06. You see the values are getting smaller, okay, and it is set 4.9706 right now, and I'm getting same equal 2 decimal places. Then I will just write basically my x approximates to 4.97 by looking at the latest calculation, because after the 7 the next digit is 0, so we can just ignore the 06. No rounding off here. Next question, number 5, first part. By expanding this, okay, cube of cos square x plus sin square x, or otherwise show cos power 6x plus sin power 6x equals to these two terms. So since we are given a hint, by expanding this, then I will start with cube of cos square x plus sin square x. So we will do expansion. This cube I will change to cos square x plus sin square x degree 1 multiply with degree 2. Okay, and for the second expansion, I will have to use quadratic expansion here. Square of a plus b, that is a squared plus 2ab plus b squared. Then you will be getting, this is cos square x plus sin square x. So now my a becomes cos square x. So it will be cos degree 4x. Okay, so for information, cos square x then square. This is same as cos x square and then another square outside. Therefore, it becomes cos x degree 4. This cos x degree 4 is same as cos degree 4x. Right. Then from here, you will be getting plus 2 cos square x sin square x. Then lastly, that is sin degree 4x. And now here, I will do expansion. So this cos square x times into the whole bracket. Right? So you just change the first term into cos degree 6x because we have this formula. A power m times a power n. That is a to the power of m plus n. Okay, cos square x is square of cos x. Cos degree 4x is degree 4 of cos x. So since both base equals to cos x, therefore we just add the degree. So 2 plus 4 becomes 6. So that is the explanation. And then now plus 2 cos square times cos square becomes cos degree 4x. Sin square x. Cos square x times sin degree 4, just rewrite. Okay, after that, followed by sin square x multiplied to the whole bracket. Then you will be getting plus sin square x cos degree 4x. Sin square x times 2 cos square x sin square x. That is going to be plus 2 cos square x sin degree 4x. And then plus sin square x times sin degree 4. That is sin degree 6x. Okay, then from here, you see the left hand side, we have one identity. Sin square x plus cos square x is basically 1. That means this is 1. Okay, so which means now I will write 1 cube equals to, now for the right side I will group the term with the same degree. This is cos degree 6, here is positive sin degree 6. So they will be grouped together. That will be cos degree 6x plus sin degree 6x. Okay, then after that, I will simplify. This is cos degree 4x sin squared. Here is cos degree 4x sin squared. So when I plus together, that is 3 times. And same goes to the other one. This is cos squared sin degree 4, cos squared sin degree 4. So both will be the coefficient of 3. So I will factorize the 3. Then I will write cos degree 4x sin square x plus cos square x, sine degree 4x. Okay, now, when you look at the question over here, we need to prove cos degree 6x plus sine degree 6x. That means now I will make these two terms as a subject, which means I will move this 1 cube to the left side. Okay, or probably I will just keep the cos degree 6x plus sine degree 6x on one side, and then this plus 3 together with the bracket will be moved to the other side. Okay, then from here you will be getting cos degree 6x plus sine degree 6x. 1 cube is 1, so minus 3. Then I rewrite the rest. Okay, so when you look at the answer on the right side here, I have found the 1. But instead of 3, I need to get 3 over 4, and at the same time, sine squared 2x. So which means now I need to factorize the common term. Okay, so I will write this as 3. So when you compare the terms inside the bracket, the common term will be sine squared and cos squared. Okay, this will be the smallest degrees for these two terms. So I will write down sine square x, cos square x. So then, after you factorize the sine square x and cos square x, first term still have cos square x. And the second term still have sine square x. Okay, remember, sine square x plus cos square x is 1. Therefore, this is going to be 1 minus 3 sine square x cos square x. Because cos square x plus sine square x equals to 1. And now, I need to get sine 2x, right? So, refer to the sine 2x formula. Sine 2x or sine 2a is basically 2 sine a cos a. So now here, I have the sine squared and cos squared over here, right? That means I may get this as a subject, which means sine a cos a, that is half sine 2a. And now when you compare, this is sine square x cos square x, I can rewrite in this form. That is going to be 1 minus 3, then I take out the squared. It will be sine x cos x squared. And now, this sine x cos x will be replaced by half sine 2x because my a is x now. Okay, so my a is x. Therefore, now I will change to 1 minus 3 times half sine 2x and squared. So obviously, when you square the bracket, square the half, it will be 1 over 4. Square the sine 2x, that will be sine squared 2x. And now I just need to rearrange. That will be 1 minus 3 over 4 sine square 2x. So when you compare with the question there, it's exactly the same now. That means we have shown the given form. Okay. Now part 2, hence means use the previous answer, solve the equation. So now we have proven this on the previous part. So I will write cos degree 6x plus sine degree 6x equals to 1 minus 3 over 4 sine square 2x from the previous part. And now you need to solve, that is equals to 2 over 3. That means right side is 2 over 3. So 1 minus 3 over 4 sine squared 2x is 2 over 3. Okay, so now to solve this, I will move this negative term to the right side, and half the 2 over 3 will be moved to the other side, which means now here I will be getting 3 over 4 sine squared 2x, that is 1 minus 2 over 3. So 1 minus 2 over 3 is basically 1 over 3. Okay, now I need to get the sine as a subject, which means the 3 over 4 move down. So sine squared 2x, when you move down, means that the 3 will be moved down and combined with the 1 over 3, that is 4 over 9. That means now here, sine squared 2x is 4 over 9. So sine 2x, that is plus minus square root of 4 over 9 because of the even degree. Right? So here I will be getting plus minus 2 over 3. And now look at the interval. Your interval is given x from 0 to 180 degrees. And now we have found sine to x. Therefore, now I have to find the new interval, right? So I will just write here, given 0 to 180 degrees for 1x. Therefore, if it is 2x, then I will have to times 2 to the whole inequality. That becomes 0 and 360 degrees. Okay, so now I will draw the quadrant. So since your sign will be plus and minus, that means you have to consider all 4 quadrants. Now I will get the basic angle. Basic angle is basically at sine 2 over 3. Ignore the plus minus. I don't consider the minus because the minus is basically the quadrant, right? Even the plus is also quadrant. For the basic angle, we always consider the positive value. So using calculator, right, you will be getting 41.81 degrees. So here I give more decimal places because later I need to divide by 2 in order to get the x. So I will label all this as 41.81 degrees. Now by looking at the latest interval, so we can accept the values of 2x from 0 to 360 degrees. That means my first angle is the basic angle. Then my second angle will be the angle in the second quadrant, that is 180 minus 41.81. And then my third angle will be in the third quadrant. That means you have to plus 180 to 41.81. And lastly, it will be the fourth angle, which is in the last quadrant. So which means now here, all this still belongs to 2x. So I have to write 2x equals to first angle 41.81. Second angle is in second quadrant, therefore 180 minus 41.81, and you will be getting the angle of 138.19. Okay, the third angle, the basic angle plus 180 degrees, that is 221.81 degrees. And the last angle, that is 360 minus the basic angle, then you will be getting 318.19 degrees. So all these values are within the interval. That means we are safe. So now, final answer to get the x. So all of this divided by 2, and you round up to 1 decimal place because the angle is in degrees. So therefore, after I have rounded up, the first value is 20.9 degrees, then followed by 69.1 degrees. The third will be 110.9 degrees, and the last one is 159.1 degrees. So this will be the solution of this question. Okay, next question, number 6, first part. Express 1 over 4 minus y squared in partial fractions. So now, when you look at this rational function, I will say that this is proper rational function because the degree of the y in the numerator is 0. That's why you don't have the y. The degree of the y in the denominator is 2. So when the degree of y in the numerator is less than the denominator, this is called proper rational function. That means you can find partial fractions directly. Otherwise, you have to perform polynomial division. Now, for partial fractions, we need to have minimum 2 factors in the denominator. And this denominator right now, I can change into this form. Okay, it will be 1 over 2 squared minus y squared. And then apply the difference of squares. A squared minus b squared, that is going to be a minus b times a plus b. This is a formula. And now here, I will be getting this as 1 over 2 minus y times 2 plus y. Okay, then now from here, I will start finding my partial fractions. So since both are linear factors, therefore I will get a over 2 minus y plus b over 2 plus y. Okay, so now to get the a and b, we need to get the same denominator. So what I need to do is I compare. Here is 2 minus y. That means I need to times with 2 plus y. So a over 2 minus y times 2 plus y over 2 plus y. So that you get back the previous step. And for the b, when you compare with the left hand side, I have 2 plus y now. That means I need to times with 2 minus y for the numerator and denominator. So left hand side I will just rewrite. So we are using comparison method to get the factors. So then since all of them are having the same denominators, you can just cancel off and then write down the numerators to solve the a and b. So then I will be getting 1 equals to a times 2 plus y plus b times 2 minus y. Okay, so let the factor be 0. So the factor is 2 plus y and 2 minus y. So let 2 plus y equals to 0. That means y equals to minus 2. I'm using the substitution method. But I do not simply substitute the y, but I will just refer to the factors and let the factor be 0. So substitute this y equals to minus 2 into the previous step. Left side remains as 1. It does not depend on the y. Then right side, since I let this 2 plus y be 0, means 0 times a, first term becomes 0. Then I will be getting b bracket 2 minus minus 2, because your y is minus 2. That means now you are getting 4b is 1, hence your b is going to be 1 over 4. Now next step is let 2 minus y be 0. That is our second factor, hence your y is 2. So same steps as previous. So 1 equals to, replace the y plus 2, y by 2 now. It will be 2 plus 2. And then the second term, the term with the b will be 0 because I let 2 minus y be 0. Then from here, again, 4a is 1. Therefore, a equals to 1 over 4. So once you have found the a and b, right, substitute back into this step, the partial fractions. So I will be getting 1 over 2 minus y times 2 plus y equals to, okay, since your a and b are both 1 over 4, means that instead of writing 1 over 4 over 2 minus y plus 1 over 4 over 2 plus y, I will just factorize 1 over 4. So once I have factorized 1 over 4, I will get 1 over 2 minus y plus 1 over 2 plus y. So this will be your partial fractions. Now part 2, the variables x and y satisfy the differential equation. When y equals to 1, x equals to 1, solve the differential equation, obtaining the expression for y in terms of x. So now we need to get the y as a subject. Now x dy dx equals to 4 minus y squared. To solve the differential equation, we need to separate the variables. But by looking at the dy dx on the left side, the dy is the numerator. Therefore, all your y should be on the left side. That means the dx will be moved to right side together with the x. So I will be getting 1 over 4 minus y squared dy. That equals to the x, when you move down, it becomes 1 over x. Because at first it was multiplication. So now 1 over x dx. And at the same step, add the integration sign. Okay, so that is the separable variable method. Now, for the left hand side, 1 over 4 minus y squared already found the partial fractions. So I will replace by these partial fractions by factorizing 1 over 4. Okay, then the right side I will just remain. Now, remember, when you look at the left hand side, both denominators is degree 1. Okay, are degree 1, right? So I will use the ln formula. So the ln formula is basically integrate f prime x over fx dx. This is going to be ln of the denominator, then plus c. So now when you look at the first term, okay, I will split into two terms now. It will be 1 over 4 integrate 2 minus y dy plus, I split into two integrations. Now, when you refer to 2 minus y, look at this formula. My numerator is a differentiation of denominator. So when you differentiate 2 minus y, it's supposed to be minus 1. But then when you look at the previous step here, this is positive 1. So I need to get positive 1 from minus 1. That means I need to times another minus outside. Okay, then for the second term, where I differentiate 2 plus y, that is 1. And now when you compare with this form, this term is exactly the same. That means I will be getting ln later on. Okay, so we are allowed to times a constant outside to make it to f prime x. You are not allowed to times functions of x, right? If you need to times functions of x, means that the ln is not the proper method. Now, and same goes to the right side. See, if I didn't write this, when I differentiate x, again this x is with degree 1. So when I differentiate x, that is 1, exactly the same as the previous step. So which means now here I will be getting 1 over 4. The first one because of the minus outside, so I will write minus ln of 2 minus y. You can write modulus for 2 minus y if you are not sure whether 2 minus y is positive or not. But if you are sure that 2 minus y is positive, you can just write brackets instead of modulus. Then the next integration is basically ln of 2 plus y, modulus. Then right side, this is ln of x. And now, since all these integrations without limits, you're supposed to plus c or plus arbitrary constants to each of the integrations. But now I will just say that the total of the arbitrary constants will be just plus c. Okay, I will just write plus c on right side, only 1 plus c. Then from here, I will start finding c by replacing x and y values. So x is 1, y is 1. Right? Then from here, I will write 1 over 4 minus ln. So 2 minus 1 is 1 plus ln 2 plus 1 is 3 because your y is 1. And right side, ln x is 1, then plus c. So basically, ln 1 is 0. Okay, so my c is 1 over 4 ln 3. Then, after I found this, the question says, find the y in terms of x. That means the y is a subject, which means now I have to substitute this c into this step. Okay, I will rewrite. So I will get 1 over 4 minus ln 2 minus y plus ln of 2 plus y equals to ln x plus the c, 1 over 4 ln 3. Okay, so we have one identity, ln a plus ln b, or I would say ln a minus ln b, that is ln a over b. Okay, so now I have to times the whole equation by 4 first, because I don't want the 1 over 4. I want to eliminate the 1 over 4. So I times 4 to the whole equation, and at the same time, for the subtraction of 2 ln, I will combine it into division of 1 ln. So here becomes ln of 2 plus y over 2 minus y, put a bracket, then equals to, this is 4 ln x, okay, plus ln 3. Now, for the right side, we have 2 ln, but then before we multiply, or before we combine, because our ln a plus ln b is going to be ln ab. Before we combine, we have to make sure the coefficient is 1 first. Then we have to apply another formula. A ln b is ln b to the power of a. So which means I will have to write this is ln x degree 4 plus ln 3 first, before I combine the 2 ln using the second formula. So now I can combine. So then when I combine, it will be multiplication because of the plus. And now, on left and right side, you are getting only 1 ln. Therefore, the ln can be cancelled off. Then I will be getting 2 plus y over 2 minus y equals to 3x degree 4. Okay, and now to get the y as a subject, which means this 2 minus y will be moved up. Then I will be getting 2 plus y equals to 3x degree 4 multiplied with 2 minus y. And now I will do expansion. So therefore, you will be getting 3x degree 4 times 2, that is 6x degree 4. Then 3x degree 4 times minus y, that is minus 3x degree 4 y. And left side just remains. So the y, the term with the y will be grouped together. Okay, so I will move the term on right side to the left side so that all my y should be on the all my y will be on the left side, and these two will be moved to right side. That means now here I will be getting y plus 3x degree 4y equals to 6x degree 4 minus 2. And factorize the y, then you will be getting 1 plus 3x degree 4 equals to 6x degree 4 minus 2. And now your y will be 6x degree 4 minus 2 over 1 plus 3x degree 4. So that is our working. This is not yet the final answer because I noticed that my numerator, the common term is 2. So you may factorize a 2, then you will be getting 3x degree 4 minus 1 over 1 plus 3x degree 4. So this is our y expression. Okay, question number 7. Throughout this question, the use of calculator is not permitted. Now, first part, express cos theta plus 2 sin theta in the form r cos theta minus alpha. Give the exact values of r and tangent alpha. Okay, so when you need to do expansion for this, or when you need to find r and theta, r and alpha, you have to be careful when this is cos. Here, first term must be cos, because our formula is a cos theta plus b sin theta. This will be r cos theta minus alpha. Then the r is going to be square root of a squared plus b squared. That's why if here cos, this is cos. But for cos, it will be opposite sign. When here minus, inside the bracket, it should be plus for the expansion. And then the alpha value is basically arctangent b over a. Okay, so now when you compare, I'm getting the cos as a first term. That means my a is 1. Okay, therefore my r is basically square root of 1 squared plus 2 squared, and you are getting square root 5. So exact values of r. And now you need to find the exact value of tangent alpha as well. So we know that alpha equals to inverse tangent 2 over 1. Okay, that means alpha is inverse tangent 2. And now firstly you have to express this in r cos of theta minus alpha. That means now I need to find out what is my alpha first. So basically, that means now here I will just write, it will be cos theta plus 2 sin theta equals to square root 5 cos theta minus arctangent 2. And now you need to get your tangent alpha exact value. So since alpha equals to arctangent 2 or inverse tangent 2, that means now I can just move this inverse tangent to the left side. That will be tangent alpha is 2. Okay, so done for the first part. Now, hence has misused the previous answer, showing all necessary working, show that this integration equals to 5. So now, let's check. We have found the expression for cos theta plus 2 sin theta. That is square root 5 cos theta minus inverse tangent 2. That means now here, I will replace this, right? So, integrate 0 to 1 over 4 pi 15 over cos theta plus 2 sin theta squared. So then I will change the denominator by using the previous form and factorize the numerator 15. So I factorize 15, then get 1 over limits 0 to pi over 4. So square of cos theta plus 2 sin theta, I will change to square of this value. Okay, and then I will write my alpha first. So later the alpha will be replaced back. So then here I will just write, okay, from first part, cos theta plus 2 sine theta, that is square root 5 cos theta minus alpha, where the alpha is arctangent 2. Okay, so here I will write square root 5 cos theta minus alpha, then squared. So when you bring in the squared, it will be 15, then integrate 0 to pi over 4, 1 over square of square root 5, that is 5. Square of cos, that is cos squared. Okay, and again the 5 can be taken out. So here, when I taken out, it will be, when I factorize the 5, it will be 15 over 5. So here I will get 3. Integrate 0 to pi over 4. Now 1 over cos squared is basically secant squared. Okay, so we can integrate secant squared by using tangent. So this is going to be 3 tangent theta minus alpha 0 to pi over 4. Okay, and then now you replace the value. So I will get 3 tangent theta, my theta is pi over 4, minus alpha. Then I minus tangent when theta is 0. So you will get minus alpha. And now remember, tangent minus alpha is minus tangent alpha. This is in the formula list, right? So then from here, I will get 3 of tangent of pi over 4 minus alpha. This minus tangent minus alpha is negative tangent alpha. So the negative together with the negative becomes positive. Now remember, just now we have found tangent alpha is 2. So then now here, remember, tangent alpha is 2, right? And for the first term, this part, tangent of pi over 4 minus alpha, we can use this formula, tangent A minus B, that is tangent A minus tangent B over 1 plus tangent A, tangent B. So this is going to be 3 times tangent pi over 4 minus tangent alpha over 1 plus tangent pi over 4 tangent alpha, then plus tangent alpha. Okay, and now I'm going to replace the tangent alpha by 2. So this is going to be 3 times 1 minus 2 over 1 plus tangent pi over 4 is basically 1. So 1 times 2, then plus 2, whereby the tangent alpha is 2. So from here, I will be getting 3 times 1 minus 2 is minus 1. 1 plus 2 will be 3, then plus 2. So this is going to be 2 minus 1 over 3 is 5 over 3. So at last I'm getting 5. So this is the integration. Next question, number 8. The equation is given where A is non-zero constant. Now first part, show the dy dx is this expression. So now here what we do is, you are given the implicit equation and we need to get the dy dx using implicit differentiation. So I will just rewrite the equation. So first term, when we differentiate with respect to x, the dy dx is when we differentiate with respect to x. That means now when I differentiate the whole equation with respect to x, the first term becomes 6x squared. Now for the second term, to differentiate y with respect to x, this is the formula, that is the chain rule, which is we are able to differentiate y with respect to y, then we times with dy over dx. So now here, when I differentiate minus y cubed, it will be minus 3y squared times by dy over dx. And for the second term, the third term, I factorize a minus, and now I will let my 3x be the u, v be the y squared, and I apply the products rule. So this is going to be minus 3. Keep the x, if you still remember the products rule, differentiate u v, that is u v prime plus v u prime. So I will get x, differentiate y squared with respect to x. This is going to be 2y dy over dx plus, keep the y squared, differentiate x is 1. Then for the right side, since your a is the constant, that means differential constant, it will be 0. So now to get the dy dx, I will, firstly I will divide the whole equation by 3. Then you will be getting 2x squared minus y squared dy dx. Then this minus will be bring into the bracket, and this 3 will be cancelled off. That means I will be getting minus 2xy dy dx, and the minus times by the y squared, it will be minus y squared equals to 0. And now for the terms with the dy dx, I will make it to positive. That means these two terms will be moved to the right side. Therefore, when I rewrite y squared dy dx plus 2xy dy dx, so the 2x squared and the minus y squared will stay on the same side. I will be getting 2x squared minus y squared. And now for the dy dx to be the subject, I will just factorize dy dx. Then you will be getting y squared plus 2xy on the left side, and right side just remain 2x squared minus y squared. At last, the brackets will be moved down to right side. Then you are getting the given answer. So we have shown this dy dx. Part 2, find the coordinates of the 2 points on the curve at which the tangent is parallel to y-axis. So now, for information, if let's say you are given this graph, tangent parallel to x-axis means dy over dx equals to 0. When the tangent is parallel to x-axis, right, that means it is infinity because they are perpendicular to each other. So that means here dy dx equals to infinity. So infinity happens when it is any values divided by 0, which means now to get this tangent parallel to y-axis, which means my denominator of the dy dx must be 0. So now I will just let this be 0. Okay, so my y squared plus 2xy will be 0. Then from here, I will factorize the y, the common term. Then you will get y plus 2x equals to 0. Products of two terms equals to 0 means that one of them must be 0. So which means either y equals to 0 or y plus 2x equals to 0, or y is negative 2x. And now we need to find the coordinates of the 2 points. I have to substitute these two results, y equals to 0 and y equals to minus 2x, into the curve equation, into this. Right? So I will copy the curve equation first. So from the curve equation, it will be 2x cubed minus y cubed, then minus 3xy squared equals to 2a cubed. So now from here, replace the y by 0 first. So when y equals to 0, let's say this is the first equation, I will get 2x cubed minus, the right side will be 0, then I will get 2a cubed. So obviously your x equals to a. So I get a point. Alright, so which means point with coordinates a0. Then now here, when y equals to negative 2y, negative 2x, right? That means now here, okay, basically no need to label this as first equation. So I will replace now, you will be getting 2x cubed minus, the y is negative 2x. So negative 2x, then you cube it, then minus 3x, the y is replaced by minus 2x, and square it. That equals to 2a cubed. Then from here, you will be getting 2x cubed. So the cube of the minus is minus. The minus minus is a plus. Now bring in the cube to the 2 and also to the x. So 2 cubed is basically 8. So I'll get 8x cubed. And then you bring in the square to the minus. This is positive. So positive and minus end up with minus. And also bring in the square to these two terms. So basically I'm getting minus. So 2 squared is 4. 4 times 3, 12. So it will be 12x cubed equals to 2a cubed. So for the left hand side, 2 plus 8, 10. 10 minus 12 is minus 2. So I'm getting minus 2x cubed equals to 2a cubed. So obviously, your minus x cubed is a cubed. That means now your x cubed is minus a. Okay, so now my point will be with coordinates. No, sorry, not yet. I need to find my y value. So, sorry, this is x. Alright, so when x equals to minus a, my y is minus 2x. So you are getting 2a. That means now basically my points is with coordinates. So from here, the points is with coordinates minus a and 2a. But when I rewrite my final answers, that will be points equals to a0 and minus a to a. So these are the 2 points when the tangent is parallel to the y-axis. Question 9a. Find the complex number z satisfying the equation 3z minus iz star equals to 1 plus 5i. So this is the conjugate. I will let the z be a plus bi. Therefore, the conjugate is going to be a minus bi. So my equation becomes three times a plus bi minus I times a minus bi equals to 1 plus 5i. Then now here, when I do expansion for both brackets, you will be getting 3a plus 3bi minus ai minus bi squared. Oh, sorry, minus minus is a plus. Plus bi squared. That equals to 1 plus 5i. Okay, this is the equal complex number, but I have to simplify the left side first. We know that I squared is minus 1, which means this is minus 1. Okay, so when I combine first and last term, that is going to be 3a minus b. The second and third term can be combined after you factorize the I. So I will get 3b minus a. Then I equals to 1 plus 5i. Then from here, use the equal complex number concept, just compare the real and imaginary parts. So I will be getting 3a minus b is 1, first equation. And then my second equation is 3b minus a equals to 5. Okay, so basically from the first equation, I can get my b. So my b equals to, just move it to the right side and then 1 move to left side, it will be 3a minus 1. I let this be third equation. Now I substitute third equation into second equation. I'm using substitution method to solve the a and b. So now I will be getting 3 times 3a minus 1 minus a equals to 5. Then from here, just do expansion. So 9a minus 3 minus a equals to 5. So 9a minus a is 8a. The minus 3 move to the other side becomes plus 3. Therefore, you are getting 8. Then now my a is 1. After you found the a, substitute back into third equation to get the b. So from third equation, your b is 3 times 1 minus 1. That is going to be 2. So therefore, my complex number, because the question says solve, right, or find the z. So the z is a plus bi. Therefore, my a is 2 or is 1. And then my b is plus 2. So plus 2i. That is my complex number z. Okay, part B. On a sketch of an Argand diagram, shade the region whose points represent the complex numbers z, which satisfy both inequalities. First is modulus z less equals to 3, and the second is imaginary. Im is imaginary. Okay, so now calculate the first is shade the region. Okay, there's the first part. Second is calculate the greatest argument. Give your answers in radians, correct to 2 decimal places. Now basically for the first inequality, this is in the form of, this is actually, I would say this is actually the locus of circle, right? So this is a circle with center AB, provided this is minus, and then the radius R. So which means now here, I change to the same term or same form. It will be z minus 0 plus 0i. That means this is a circle with center, origin, and radius 3 units. Okay, so now whereby the imaginary z, okay, I let my z be y, be x plus iy. Therefore, imaginary part is basically y. Hence, my y is greater or equal to 2. Okay, so now I will draw a circle. Center, origin. Okay, so this is the center, origin. Right. Okay, so now let's say this is 2. That means here is 3. This is minus 3. Here is minus 3. This is positive 3. Here's the origin. This is real part or real axis. Okay, then this is the imaginary axis. So you can write RE, real, or REZ. This is IM. Okay, so now the first one is the less equals to 3. That means if it is 3, that is the circumference of the circle. That means it's here. But because of less, that means everything inside. okay, including inside. But then now we need to have another line which is y at least 2. So I will draw a line here, right? And the region is at least 2, means it should be above. So this is the region. Okay, so then when I need to label this circle, this is going to be modulus z equals to 3. Then this line is imaginary z equals to 2. Okay, now done for the first part. Second part is calculate the greatest argument z. So greatest argument z is basically the points with the greatest angle from the origin. Obviously, it will be here. Okay, because for the shaded region, so here is the greatest, and we know that this is actually a circle, right? This is a circle with radius 3. That means here is 3 units, and I know that this is 2 units. Okay, so now my angle is over here, my argument, greatest argument. So I will draw the right triangle. Okay, that means I will say this is 2. Here is my 2 units. That is the y coordinates. So I will draw the triangle, the right angle triangle over here. I need to find this angle, right? So or probably I just draw this triangle. I draw this triangle. That will be better. I don't draw this. I draw the other one. This is 2 units. Okay, so I can say that my angle, my argument, this is my greatest argument. There's the theta. It will be pi over 2 plus this angle. Okay, and remember the green color is radius 3 units. So I'm going to draw this triangle. That means here is 3 units, this is 2. And I need to find this angle. So this is opposite side, this is adjacent, and here is the hypotenuse. Since we have the A and H, adjacent and hypotenuse, that means I'm going to use the cos, right? So I will say greatest argument is equal to theta, which is same as pi over 2 plus. Now look at here. This value, okay, it will be alpha. Let's say alpha, right? So your alpha, I can just write cos alpha equals to adjacent over hypotenuse, 2 over 3. That means my alpha is going to be at cos 2 over 3. Okay, so then answer correct to 2 decimal places and in radians. So then you can just direct count from the calculator. This is 2.41. Radians. Okay, done for this greatest argument. Now, next question, number 10. The points A and B have position vectors. Respectively, the line L has equation. Show that line L does not intersect the line passing through AB. Okay, so from the position vector, I will just change to OA first and express in column vector form. That will be 2, 1, 3. Because 2i plus 1j plus 3k. And then my vector OB, position vector OB, that is going to be 4, 1, 1. Now, look at the question. Show that it does not intersect the line passing through AB. That means now I need to form the line AB first. The vector equation. So I will count AB, vector AB, that is OB minus OA. Then this is going to be 4, 1, 1 minus 2, 1, 3. So 4 minus 2 is 2. 1 minus 1 is 0. 1 minus 3 is minus 2. You can express in this form or you can factorize the 2, up to you. Okay, so from here, I will say my line AB it will be RAB equals to, okay, let's say the line passes through 2 points now, A and B. I choose the A as the fixed point. You can choose a B, no problem. Right? I choose the A as a fixed point, so 2, 1, 3. Then plus lambda 2, 0, negative 2. You can write 2, 0, negative 2, or you can write 1, 0, negative 1 for the direction vector, no problem. So now the line L has this equation. So line L, so RL equals to 4i, 6j, there's no k. So 460 plus mu 1i, 2j minus 2k. 1, 2 minus 2. Okay, now, even though we need to show does not intersect, right? We just let both be equal first. So RAB equals to RL. So now we are open the bracket, right? So 2 plus 2 lambda. Then 1 plus 0 lambda, so 1. Then after that, 3 plus negative 2 lambda. So 3 minus 2 lambda equals to, my RL will be 4 plus 1 mu. So 4 plus mu. Then 6 plus 2 mu. After that, 0 plus mu times minus 2. So minus 2 mu. Let this be 3 equations. Now, to show that 2 lines do not intersect, we need to choose any 2 equations to solve. And to solve for both parameters, after that, we have to substitute both parameters into the remaining equation. Okay, so from here, I will just choose, okay, now I will choose look at the equations here, right? I will solve the second and third equation, right? So when I solve the second and third equations, basically here plus 2 mu, this is minus 2 mu. So to eliminate the mu, I will just plus these 2 equations. So I will write second plus third. I'm solving these 2 equations. So for the left hand side, 1 plus 3, 4. 0 minus 2 lambda is minus 2 lambda. Then right hand side, 6. The 2 mu will be cancelled off. That means from here, my 2 lambda will be basically 4 minus 6. That is going to be minus 2. Okay, or probably you can just solve the second equation first, get the mu. So we can find the mu directly. Then substitute into first or third, up to you. Then from here, my lambda equals to minus 1. Now, since I use the second and third, that means you have to use second and third to find the mu. So I will just substitute, or I will just refer to second. I should have solved the second first. Right? Probably I rewrite my working. I will say I don't want to solve the 2 simultaneous equations, but I solve the second equation first. So from second equation, my 2 mu equals to 1 minus 6. That is minus 5. That means my mu is minus 5 over 2. Okay, then I substitute into third equation. Substitute into third equation. So I will get 3 minus 2 lambda equals to minus 2 mu. Then here, cancel off. You will get plus 5 on the right side. So 3 minus 2 lambda is 5. Therefore, 2 lambda equals to 3 minus 5. That is minus 2. Then you are getting lambda is minus 1. I get these 2 values from second and third equations. That means now I have to substitute back into the first equation for checking. So from first equation, my left hand side equals to 2 plus 2 lambda. That is 0. Then my right hand side, that is 4 plus mu. So you will be getting 3 over 2. So then, now left hand side not equals to right hand side. Therefore, both lines do not intersect. Okay, so just for information, for do not intersect case, if you choose other two equations to solve, your parameter will be different. Okay, so then that is the solution for this question. Now, the points P with parameter T lies on L and is such that angle PAB is equal to 120 degrees. Show this quadratic equation, hence find the position vector of P. So what we need to do here is, since P lies on L, that means your OP will be the RL. So now here I will just rewrite my RL will be this 460 plus mu 1, 2 minus 2. So when I open the brackets and combine together, that will be 4 plus mu, 6 plus 2 mu, lastly minus 2 mu. That is my OP. And now, given the angle PAB, so I simply sketch a diagram. PAB, the angle is 120 degrees. So now, for the angle formulas, which is the scalar product formula, make sure two vectors are pointing out. So then I will start with AB dot AP. Okay, so I need AP. So which means now I write down my AB first. My AB from previous calculation, 20 minus 2. And now I need to find the AP. So my AP vector is OP minus OA. That is going to be 4 plus mu, 6 plus 2 mu minus 2 mu. Then you minus the OA is going to be 213. So then I will be getting the vector as 4 minus 2 is 2, then plus mu. 6 minus 1 is 5, then you plus 2 mu. Lastly, minus 2 mu minus 3. I will just write minus 3 minus 2 mu first. This will be my vector AP. And now, according to the scalar products formula, so AB dot AP equals to magnitude AB cos theta, cos angle PAB. Okay, then from here, AB dot AP, so I will write 2 times this. So it will be 2 times 2 plus mu plus 0 times 5, that means it's 0. 0 times 5 plus 2 mu is 0, plus negative 2 times minus 3 minus 2 mu. That is the dot product or scalar product, right? So then from here, I will write the magnitude is square root of 2 square plus 0 square plus minus 2 squared for the AB. And then for the AP, you need to square all this and plus. And now cos 120 degrees. Okay, then from here, for the left hand side, just do expansion. So I will be getting 4 plus 2 mu. Okay, then, okay, let me see my RL. Oh, wait. Okay, now P with parameter T. Okay, so it means that I cannot use mu. I have to use T, parameter T. Sorry. So this is T. So all of this you must change to T. Otherwise, you won't get T later on. So I change to t first. Okay, then now here change to t. Same goes to the right side. All the mu change to t. Okay, so for the next expansion, minus 2 times minus 3 is plus 6. Minus 2 times minus 2 mu plus, okay, no more mu. This is t. So that is 4t. So the first square root, this is going to be square root 4 plus 4. So square root of 8. Square root 8 is 2 square root 2. Right? And square root, I will do expansion for this, which is a quadratic expansion. Use the quadratic formula a plus b squared equals to a squared plus 2ab plus b squared for all this expansion. Then you will be getting 4 plus 4t plus t squared for the first expansion. Second expansion is 25 plus 20t plus 4t squared. The third expansion, 9 plus 12t plus 4t squared. Okay, cos 120, that is positive half. So now on the right side, the half and 2 cancel off. So basically you get square root 2 times another square root. So now I will simplify the second square root first. There are so many terms. So therefore, you will be getting left side 10t, 6t, 2t plus 4t, 60. So 10 plus 60, that equals to square root 2 times another square root. So for another square root, see here, 4t squared plus 1t squared plus 4t squared. This is just 9t squared. Okay, after that, 40, right, 40, 20t, 12t. Total will be 36t. Positive. And then for the constant wise, you will be getting so for the constant, you get 4 plus 25 plus 9. So 4 plus 9, 13, 13 plus 20 plus 25, that is 38. Okay, so for the right side, we can combine the two square roots using this formula, square root a times square root b, that is square root ab. That means now here, I will be getting square root of 2 times 9, so 18t squared, 2 times 36, that is 72t, 38 times 2, that is 76. And now to eliminate the square root, because we need to find the t, okay, or we are not finding the t, we need to show this quadratic equation. So we need to square both sides. So when I square both sides, I'm actually squaring both sides. So the square and square root cancel off from the right side, but the left side I still need to do expansion. This is going to be 100 plus 120t plus 36t squared. Right side, just copy the three terms. So you will get 18t squared plus 72t plus 76. So move all the terms to left side. 36t squared minus 18t squared is 18t squared. 120 minus 72, that is plus 48t. Then 100 minus 76, that is plus 24. And all of this can be divided by 6. Simplify first. Therefore, you are getting 3t squared plus 8t plus 4 equals to 0. Okay, that is the quadratic equation that we need to solve, or that we need to show. So we have shown this. Now, when you look at the question, hence, find the position vector of P. So if I need to find P, that means I need to find T, right? So which means now we need to solve this quadratic equation. So 3t squared plus 8t plus 4 equals to 0. I can factorize this into two terms, or you can just use this method. 3t times t will be 3t squared, plus times plus, plus times plus will be another plus. So plus plus for both. Then to get 4, it will be 2 times 2. So 3t times plus 2, it will be plus 6t. T times plus 2, it will be plus 2t. So then you will be getting 3t squared for the first term, and the third column, when you multiply, it will be plus 4. Second column you plus, these two you times. So 6t plus 2t plus 8t. Now your factors, you just cross multiply. This is how we factorize it. Or probably you can just use calculator to get the root. Then from the root, you convert to factors. Then you will be getting 3t plus 2 multiplied with t plus 2 equals to 0. Then now here I get 2t values. So either 3t plus 2 equals to 0, then your t equals to negative 2 over 3, or t plus 2 equals to 0, t equals to negative 2. But then when you look at the question says we need to find p, means 1t, right? So here, find the position vector of p. So now I have to check which t that we need to accept. Now, it's okay. You can check using this. You can check using this scalar product formula. So which means I need to find out what is my AP first. So I will substitute my t value into this vector, 2 plus t, right? So now when t equals to negative 2 over 3, my AP equals to 2 plus t, 5 plus 2t. So 2 plus t, 5 plus 2t, and lastly minus 3 minus 2t. Then here is going to be 4 over 3, 11 over 3, minus 5 over 3. Okay, the purpose I find the AP is because I want to check this. So now I will count I will consider what is my AB dot AP first. So my AB dot AP, that will be my AB, which is this. So I will just replace, right? 4 plus 2t, which is 10 plus 60. I will say it is 10 plus 60. So it will be 10 plus 6t. That is 10 plus 6. Oh, sorry. So if this is the case, basically I do not need to find out what is my AP, right? Because I already found the t, I can just substitute into this part, AB dot AP. This is another easier way. So instead of counting the vector AP, so basically no need to count the AP. Vector AP no need, because if you count the vector AP, then you have to count the dots product, right? Since the dots product already counted just now. So that is I just noticed that is the easiest way. So AB dot AP equals to 10 plus 60 from this step. So now you just replace 10 plus 60. That is 10 plus 6 times negative 2 over 3. Then here you will be getting 10 minus 12 over 3. So this is 10 minus 4, that is 6. Right? But then when you look at the right side, modulus AB modulus AP. So modulus AB dot times modulus AP. So this is from the scalar products formula. or I will say from first. Probably I label this as first, right? From first, right hand side, then cos 120 degrees. So now from here, let me check. Okay, this cos 120, it should be a negative, right? I miss out the negative in the previous step. This one should be a negative, right? That means you still have a negative over here. So there's a negative outside. But since there's a negative, you square it, it still becomes positive, right? Sorry, I missed out the negative in the previous step. So then I would realize that this end up with less than 0. Okay? Because your, alright, as modulus AB is greater than 0, modulus AP is a magnitude greater than 0, cos 120 is negative half, which is less than 0. So we multiply all this. This is basically less than 0. So I will just write here. Right? So now, but then for the left hand side, the AB dots AP is positive 6. This is positive. That means now here, right, this is the left hand side. I will write here. From first left hand side. Right? So now left hand side is not same as right hand side at this moment. So left hand side is not equal to right hand side when t equals to negative 2 over 3. That means the t cannot be negative 2 over 3. Okay, so now we check for t equals to negative 2. So when t equals to negative 2, right, from first equation, the left hand side AB dots AP equals to 10 plus 60. That is 10 plus 6, your t is negative 2. This is negative 2. That is less than 0. That means it will be same as the right hand side because your right hand side is less than 0. So right hand side is less than 0. Right? That means now here I know that t must be negative 2. Okay, so from here left side equals to right side. So now the question is asking for OP. Okay, position vector of P. So now I know that I have to substitute my t into this OP. So 4 plus t, so it's just right. So at last, OP equals to 4 plus t. And then the next component, 6 plus 2t and minus 2t. 6 plus t, 6 plus 2t and minus 2t. Okay, let me check. Alright. So that means here, I will just write my answer is basically 2. Then this is 2 as well. Then this is 4. Okay, so that is your position vector of the points P. So we have to check which t that we need to accept. Right? So then, with this solution, I have completed this paper. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos, and also stay tuned for more upcoming videos. Thank you everyone. Bye.